Assalamualaikum and hi, my name is Nabila and today I will present the simulation of our question 1. So in the question, we need to design for the underdamped, critically damped and overdamp circuit for the RLC parallel. I as given in the question is equal to 4 ampere. We decided to use 4 Henry as the value of the inductor in each of the circuit. And the value of the capacitor in each of the circuit is equal to 1 microfarad. For the underdamped circuit, we use 4 kilo ohm as the value of the resistor, 1 kilo ohm as the value of the resistor in critically damped circuit, and for the overdamped circuit, we use 500 ohm. We can generate the graph by choosing transient analysis, and then the end time we set into 0.01 second. Output. Here I choose IL1, IL2 and IL3 to observe the current across the inductor. Press simulate, and then this is the graph generated from the simulation. The red one here indicates for IL2, that is for the underdamped circuit. The green one here, it indicates for IL2, that is for the critically damped. And then lastly, the blue one here is equals to IL3, that is for the overdamped circuit. So this is the graph generated from the simulation. This is for the current across the inductor. We can also generate the graph for the voltage across the capacitor. Just remove the IL1 here, and then we choose the voltage, and then we press simulate. So this is the graph generated from the simulation. So for the blue one here, it indicates for the V1, that is for the underdamped circuit. The green one here is equal to V2, that is for the critically damped circuit. And lastly, the red one here is equal to V3, that is for the overdamped circuit. So this is the graph generated from the simulation for the voltage across the capacitor in each of the circuit. And then we can also generate both of the variable in one graph. The output just simply add IL1, IL2 and IL3. So let's simulate. So this is the graph generated from the simulation. So for this blue one, it is indicate for V1, that is voltage across the underdamped circuit. The green one is for the V2, that is the voltage across the critically damped circuit. The red one is equal to V3, that is for the overdamped circuit. So for the IL1, IL2 and IL3, it is overlapped over here, and then we can see it's just a straight line across the horizontal axis. So that's it. That's all from me. Thank you.
Hello Dr. Atri, today I want to present for the question 2. For the question 2, for the simulation, I draw a circuit again, same like equation, but for the question, for V1 state 120 and V2 state 80. And for the simulation, before this, the question is in value VRMS, but I convert into VPK, so the value get 169.0 volt, and for the V2 we get 113.14 volt. And then we put the current probe at 2 ohm and current probe at 0.5 Henry, and then we also put the voltage probe at 0.2 Henry. For the current probe first, we want to get the I1, and for the current group. This one we want to get the value for I2, and this one we want to get the value for V0. And then we simulate the circuit. Okay. For the frequency we get 50.91. For the IRMS is I1, we get 4.10. This one, but you must convert into the polar form, and we get 4.10 ampere. For the IRMS, this is for the I2, 2.23. The value is same like a manual calculation, 2.23. And for the VO, we get 56.28, and same like a manual calculation, 56.2. And then let's move to the graph. For the graph is appear for the VO, I1 and I2. So for the voltage, we put minimum is negative 60 volt and maximum is 60 volt. For the current also, we change for the minimum is negative 60 ampere and maximum is 6 ampere. Then we get the graph like this. This one is for VO, this one is for I2, this one is for I1. That's all for the simulation question 2. Thank you.